Hello, this is Mr. Duncan again. Today I want to demonstrate why we do the invert and multiply rule when taking division of two fractions. So what most of us were taught when it came to doing fraction division is it's much easier to, instead of doing this division, to instead flip this fraction here, our divisor, and make it into its reciprocal, so 2/3 would become 3/2, and then treat it as a multiplication problem. So this would become, in essence, 1.5 times 3/2. And then proceed as if it were a multiplication problem. What's problematic is most people do not understand why we are even allowed to do that. What have we done with our pieces? What have we done with these quantities that we've ended up with? And more importantly, what's our end answer become? What is our answer going to be to this problem? What's the quantities that we're dealing with now that we have changed the operations? So today we're going to go through and discuss why we are allowed to invert this divisor and then multiply it by it, which is the same as multiplying by its reciprocal. We're going to find out why that's the case. So we're going to treat this like fraction division from a measurement perspective. What that means is we're going to start off with 1.5 units of some stuff, and then we're going to see how many groups of size 2/3 we can make with 1.5 units of stuff. So let's start by drawing out our 1.5 units. Okay, so this right here will be our whole. This is 1 unit or 1 whole. Okay, and we have 1.5. And we can see that this is a half because we have 2 pieces would make a whole unit, but we only have 1 of that size piece. So this dotted line just shows how many of these size pieces we would need in order to have a whole. Okay, so right now this is 1.5. Okay, our job initially is to find how many groups of size 2/3 we can make from this 1.5. So let's go ahead and draw out how big these 2/3 are. So they're the same size unit as our the quantity we start with. So let's go ahead and draw out the same quantity. Okay, and we will partition this to 3 equal size pieces. So here's our 2/3. 1, 2. All right. We want to see how many of these. This size group, so this is a group right here, how many 2/3 we can pull out of these? How many groups that are this big, of size 2/3, we can pull out of 1.5? Okay, whenever we deal with quantities like this, I find it's always easier to have the stuff I'm starting with all the same size, which means I cut all of my holes up into the same size fractional amounts that I have. So right now I have a half over here, so I'm going to partition my hole so that I have halves as well. Okay, and there's absolutely nothing wrong with that. We haven't changed how much stuff we have. But now instead of saying 1 whole and a half of a whole, I'm going to say that I now have 3 halves, or 3 pieces where it takes 2 of them to make 1 unit. So this is the same as 3 halves. Okay, and this down here, of course, is this is a 2/3 group. Okay. So 1 group is 2/3 in size, okay? So let's put that 2/3 sized group, okay? So every time you find 2/3, that's 1. Find another 2/3, that's another 1 group. So that's our job right now. How many of these groups can we make? All right. So traditionally, what we would do is make sure that we have a common partitioning between the stuff that we have and the group sizes that we want to make. That way it's easier for us to see how many pieces we need to make a full group. That's the normal process, so we can do that really quickly just so we know where we stand and what kind of answer we should be getting. So right now these are in terms of halves. These are each 1/2 in size. These 2 pieces are in terms of thirds. So they are not the same size pieces. Right? Halves and thirds are not the same size. We need them to be the same size. In order to do that, we need to find a common partitioning, a way of cutting these pieces up and perchance cutting these pieces up so that they are the same size. We find that the first common partitioning between halves and thirds will be sixths, which means we need to cut up our halves into 3 pieces each. That'll give us a total of 6 pieces making up our whole. And we're going to have to cut up our thirds into 2 pieces each, and that will give us sixths down here. So we will do that now. Let's choose a nice neutral color. So we're going to cut these up into 3 equal-sized pieces. Okay. And you could cut them lengthwise. In fact, it probably would be better in this case if we did so. Just that way you can see the pieces really are the same size. Okay. All right. So now we have 1, 2, 3, 4, 5, 6. 6 pieces make up one whole. See, it's still a whole. We now end up with a total of 3, 6, 9 pieces. So our 3 halves has now been partitioned, and we now instead have 9 fourths. Notice we haven't added any extra pieces. All we've done is chop up the pieces we already started with. So now we have 9 quarters, and I'll make that a little bit darker so we can see that. Okay, so we have 9 pieces. Excuse me, 9 sixths. My apologies. We have 9 pieces. It takes 6 of these size pieces to make a whole. Now, 2/3. They're not the same size yet. These are in terms of 6 pieces making a whole. These have 3 pieces would make up a whole. So we are going to partition our thirds each into 2 equal-sized pieces. And we do so, we see that we now have 4 pieces here where 6 would make a whole. So this now has become 4 sixths. So now we can easily see 6 pieces make up this whole, 6 pieces make up this whole. These pieces are the same size. They may not look like it, but they are the same size because they are the same size whole. Both holes are the same size, and we've chopped them up into what we believe are equal-sized pieces. And if it takes 6 of them to make a hole here and 6 of them to make a hole here, they must be the same size. Even if their shape is different, they represent the same amount of stuff. So here we have 9 pieces, and we now know in order to make a group, we need 4, take them 4 at a time. So every time I see 4 pieces, that's a group. So let's see if we can find how many groups of 4 we can make. So there's a group of 4, 1, 2, 3, 4, and we'll change color again. And 1, 2, 3, 4. There's another group, and then we have 1 piece left over. So we can see that we should be able to make 2 groups, and then we have 1 piece left over. Remember, it takes 4 pieces to make one of these groups. 4 pieces, and we got a group. So if we only have 1 piece left, and we need 4 to make a full group, that represents a quarter of our group. So we end up with having an answer of 2 full groups and 1/4 of a group. So we get 2 1/4, and the way I'm going to write this is, we're going to say 2 1/4 groups of size 2/3, or in our case, we can also say it's the same as 4 sixths, because these are equivalent. So this is what we end up with. Okay, so 2 1/4 groups of size 4 sixths. Another way of looking at it is, each one of these pieces is a quarter of this group, right? Because it takes 4 of them to make one of these groups. So each piece would be a quarter of a group. So we have 1/4, 2 quarters, 3 quarters, 4 quarters. Makes sense. 5, 6, 7, 8, 9 quarters. So we could also say that we have 9 quarter groups. 9 quarters groups. All right. Also of size 2/3 or 4 sixths. Both are equivalent, and since we're dealing with sixths, it makes sense to write 4 sixths there. And we know that 9 quarters, that simplifies to 2 1/4. So this improper fraction and this mixed number, they are equivalent. So that's the case. This is something we already knew. This is a review, basically doing basic fraction division. Our question is, where do the 3 halves crop up? You know, we can easily see how we make groups of size 2/3, but where do we see 3 halves in this picture? Do we see 3 halves anywhere? And the answer is yes. If we look right here. Originally our job was to make groups of this size, 2/3. Look down here. We can see that we have that right there is one group. Okay. If we had a whole, how many groups would that be? How many groups does this whole make up? Well, it took two of these thirds, if you see the thirds again, it took 2/3, two of these 1/3 size pieces to make one group. So each one of these would be half a group. So there's half a group, another half a group, and that makes one full group of size 2/3. But we have 3/3 here. We have 3 of those size pieces. So we don't have just half a group or 2 halves group. We have, in one whole, we would have 3 halves group. So we can say, for every whole quantity we have, that there are 3 halves groups of size 2/3. Okay? So take a minute, think about that. This group right here is composed of 2 equal sized pieces. All right? So that means our 2/3 group is, we could represent them in terms of half sizes of this. That's half of a group of 2/3, and this is a full 2 halves group of 2/3. And so if I had one whole unit, then that would be 3 halves groups of size 2/3. So every time I have a full group, one full whole, it would be the same as 3 halves groups. Groups that are each 2/3 in size. Well, the question is, how much do I have here? Well, here's one whole, and here's another half. So I have 1.5 of these 3 halves groups. I have basically 1.5 or 3 halves of them. So I can say safely now that since we have, and let's change colors so we can see that better. Since we have 1.5 wholes, we will have 1.5 of these 3 half groups, or super groups if you want to call them that. 1.5 groups of 3 halves. Okay? All right, that's how many of these we have. So that means we are going to have 1.5 groups of 3 halves. That's mathematically the same as saying we have, and we'll write this in black, this is our conclusion, that we have 1.5 groups, or 1.5 groups of 3 halves, right? All right, because really, these 3 halves represent how many 2/3 groups we have, and that was our whole premise in the first place. How many groups can we make of this size? Well, if we have a whole, we can make 3 halves groups of this size. And we don't just have a whole, we have 1.5 wholes. So we can make 1.5 of these 3 halves groups of size 2/3. So we can have 1.5 times 3 halves. And when we do that mathematics, what we're really saying is we have 1.5 groups of 3 halves groups of size 2/3, right? We have 1.5 groups of 3 halves groups of size 2/3. That's true, because here's one, right? There's one of our groups, and that's of size 3 halves of this 2/3, right? There's one group of 2/3, and there's 3 halves group of 2/3. There's one, and then we need another half. So half of 3 halves. So yeah, this makes sense mathematically. And when we do the multiplication, it becomes straightforward. We can use fraction multiplication at this point to solve this if we so wish. 1.5 times 3 halves, or we just say one group of size 3 halves and then a half group of size 3 halves. Either way, we can represent this. We can fall back on what we've been learning pictorially. If we do so, I'll just break this up as 1.5 of 3 halves. That means I should have 3 halves plus, and now I need half of this. Well, half of that would be 1.5 halves. That's kind of weird. We would instead say we can make 3/4. That would be our half piece. That would be our half group. All right. So if we add those up, we need to have similar size pieces here. So this would become 6/4, right? So 3 halves becomes 6/4. 6 plus 3 will end up being 9/4. So we end up with our answer being 9/4 groups of size 2/3. And we knew this was going to be our answer because we can see it right here. That is confirmed for us. and we are done.